So what I was going to do today is kind of take you through how I got to, my whole background. I think it's relevant because it's sort of a story of just doing what I was excited about and really not worrying too much if it didn't work out. And then get into why I went to Google to run the Google Cloud, which has just been a phenomenal experience. I was pretty hesitant to do it. And then take you through actually some of the things we're doing at Google, some of the examples of how we're using our phenomenal compute facility to do data science. I started out with a sailboat picture because I grew up sailing in Annapolis, Maryland. And I really credit it with a lot of who I am. Everybody has some, very influential part of their life. Well, for me, sailboat racing, well, one, I just love the water. I'm just always happy if I can go for a walk on the beach or go, better yet, swimming in the water or windsurfing. And sailboat racing is something that, you really have to be prepared for. You have to get your boat all tuned up. There's a lot of engineering around the boat. You have to practice with the people that are going to be sailing the boat with you, so you have to really come prepared. And then you get to a race course, and you have to kind of have researched the weather, researched the tides, researched the location, and how the tides work in that location based on the depth of the water and so on. And then you get on the starting line, and you have to figure out which end of the line is favored, and you kind of scope out your competition and who might be kind of tough, and then you do your start, and you have sort of a plan for how to go around the course. And then the race starts, and just things start changing right and left. The wind shifts don't fill in. Maybe your equipment doesn't work quite right. Some competitor is way better than you ever dreamt of. And so you're constantly integrating all this information and making real-time decisions to optimize what you have to get, to go and, in this case, win the race. And it's just a terrific sort of training ground for me. And I kind of, I got out of high school and I was racing. I raced a boat to Bermuda. I sailed a boat back from Bermuda with a friend, and I really wasn't so sure I was going to go to college. And the friend I sailed back from Bermuda with said, no, he was going to Georgetown. He goes, you really should go to college. I was in Annapolis. I had done my SATs and everything, so I was able to sign up to the University of Maryland, and I started there. I had done kind of a really engineering project when I was in high school. I was a very progressive, project-based high school that my parents had co-founded. And I saw a course about what I had done in high school, signed up for it, was the only girl in the class. And they went around the room, what is your major? And I had actually declared a major of psychology, but I thought as the only girl in the class, it wouldn't be a very good idea to say that. So the guy next to me said mechanical engineering. So I said, well, mechanical engineering. And the professor at the end asked me to stay at the end of class. He said, that's wonderful, let me be your advisor. And I'm like, oh. and so and I was there for a year. I didn't really like it. I had some friends up at the University of Vermont. They said, come up and visit. I was busy racing my sailboat. I towed my sailboat up to Burlington, Vermont, and then was sailing on Lake Champlain, and all my friends were saying, well, school's starting, we're going to go to class, and I felt kind of left out. So I signed up through continuing ed to take some engineering classes, and the same thing happened. I was the only girl, and the professor said, why are you a continuing ed student? And he matriculated me. So and then I took a year to race sailboats down in Texas. So I went to Texas A&M, and then I went back to Vermont. But because I made engineering was just the best possible major because every single credit transfers, and I got out in 4 years. So I couldn't have done it with psychology. And actually, then I went to graduate, and my head of my department called me. I had interviewed at jobs. They all looked really awful to me, big rooms full of steel desks. And my sort of head of the department asked me what I was going to do. I said, I'm going to go race sailboats. And he said, I think you should go to MIT and study naval architecture. So I had never occurred to me, didn't even know it existed. And I went to MIT, and it really changed my life because I had never been around such engaged people doing such amazing things. So I really loved it. In fact, I spent all my time with the people in the artificial intelligence lab. That was between 76 and 78. And so, but I was getting a degree in naval architecture, so I went to San Francisco. I didn't want to go to Texas where all the oil jobs were. I found my way to San Francisco, luckily, and was designing sort of mooring systems for oil rigs and how to upend them and put them in. They're the tallest structures in the world are oil rigs. Very demanding. It was all out in really exciting places to me, like the northwest coast of Australia and the North Rankin Field in the North Sea. And it turned out that women, they didn't back then have a place for women to stay on the oil rig, so I didn't get to go out to the oil. Actually, I forgot. The reason I wanted to race after after college was I did finally find a job with Schlumberger that I wanted, but they told me I couldn't go out in the field because I was a woman. And then the same thing happened when I was working in the oil industry, and it was a very conservative place. My company had an office in Texas, and they told me if I went there I had to wear a dress, and I never wore dresses. And so I just didn't go. And so then I was like, this is going nowhere. I can't go out in the field. I can't go to the main office because I don't want to, this is just not right. And so I quit, and I moved to Hawaii, and I started windsurfing. And windsurfing was just getting developed, and it was an incredibly exciting time in the world of windsurfing. We're missing a slide, I think. But anyhow, and we were designing short boards that could go out in waves and harnesses and high aspect ratio sails. And I lived there and did that. And then I got hired to run engineering for the windsurfing company in Southern California. And I went around the world doing that. It was really wonderful. I actually got very involved in a computer sail cutting project in Hong Kong to make windsurfing sails in high throughput. It was the first sort of computer cutting kind of equipment out there. All kinds of interesting technologies in the sports field. But then I eventually decided that actually I was really interested in what I had done in what I had learned about at MIT in the computer, in the software. And I went back to school at Berkeley and got a degree in computer science, a master's degree in computer science. And I always joke, I met my husband there, and that's when my boring life started because I now had a boyfriend and all that. And so so then I worked in the computer industry. I worked in the database industry, was at Sybase. My boss, the VP of engineering, was a woman. She was incredible. She was giving me all kinds of opportunities, and we were, my work led us to win all these benchmarks in databases. And one day I came to work, and she was pushing new technologies, which was new then, symmetric multiprocessors. The company, the CEO didn't think it was important. She was actually extremely right. The company almost went out of business because they didn't do it. But anyhow, they fired her. I came in, and there on my desk, she said, hey, call me, I've been fired. She put it on my desk the night before as they walked her out the door. And she went to Tandem, so I followed her to Tandem, and where she was running all of software engineering. A woman named Roberta Henderson, really incredible woman. And so I worked there. They were sort of not moving as fast as I thought they should, and I went to SGI, which is a very up-and-coming company, and there I got to work. I went there because they had the best hardware to run a database. They were using it for graphics. Ended up working on interactive television, which was the precursor to the web, and then left SGI to do startups. I was doing low bandwidth streaming video. Did a company to do that with a bunch of Stanford people that got bought by Microsoft after a year. It became their movie player, and it was kind of an amazing experience for me to do that and make all that money and be done. And so then my husband is a professor at Stanford, and he was doing some very interesting research in virtualization. I felt like I knew how to do a startup at that point. I said, hey, we should really bring this to the market. So with his grad students, we founded this company, VMware. I should say, in that time, between Tandem and SGI, I had my first kid, my son, and then when we were starting VMware, I was pregnant with our second kid, so I told everybody, look, I'm not going to do this because I'm about to have a second kid. I can't possibly do it. And then, you know, I had my daughter 6 months into VMware, and we were tiny. We didn't have customers, so I just brought her to work, and it went really well. And it was really fun working at VMware, and it was all working out. So I actually ended up being there like 10 years and running that company, building that company. And my kids grew up with me there. And my daughter, to this day, she's 18 now, she just loved it because whenever I traveled, I brought her with me. And then I would stay at a high-end hotel and hire someone to take care of her while I was at my meetings. And, you know, there's just, you know, it wasn't the traditional upbringing, but she actually valued it. And she saw me give a lot of talks, and for some, you know, she really is quite a comfortable speaker. I was never a comfortable speaker. I had to get a lot of practice before I had the nerve to stand up in front of people. But anyhow, so after VMware, I did some startups and started joining boards. I joined the board of Intuit, and then Google had an interest in me joining Google. I didn't really want to join Google, and then they said, well, you could join the board. So I joined the board of Google, which is now Alphabet. I've been on that about 6 years. And as part of that, I was very interested in seeing Google take its amazing infrastructure and do a public cloud. And we started working on it, me as a board member, and one thing led to another. And you know, one interesting thing I'll just mention when I was talking, Urs Huszel has sort of built a lot of Google's infrastructure. He was employee number 8. And he and I used to take walks when he was trying to convince me to come and do this. And I said, oh, I just really don't think I would be successful at Google. I don't feel comfortable doing this. And he said, only a woman would say that. He said, a man would just never say that. And I was like, I think he got me when he said that. And so anyhow, I did it because, you know, the cloud is this amazing place, as you know, where you can just aggregate all your data from anything, from any device. And the compute, it's a utility where you can just do so much. I mean, I think that's why machine learning is so far along, is the incredible compute you can get out of the cloud. And then, you know, the whole world moving to the cloud it's a really exciting place to be. So what I'm going to do is just kind of take you through some of the, quickly, some of the data work we're doing at Google, and I think there's time for questions at the end. And one of our really interesting products, Google had to invent a lot of data management because we have 7 applications that have over 1 billion active users. So there's a lot of data to be analyzed. So, really good tools for processing data amazingly fast. And one of our customers is Spotify. And, these are, of course, I borrowed these. They're customer slides, so they kind of boast about how fast we are. But their workload that was taking 4 hours was 12 seconds. They have over 70, this is a year ago, 75 million users. And so they use this to analyze what's going on with their users. And it's been a really fun project to work on with them. Another customer I love of ours is Home Depot. Very innovative retailer. You have to be very innovative in retail these days to compete with Amazon. And they took a huge data warehouse and have moved it to our cloud. And we recently got them through Black Friday with some incredible workloads, and have a very close partnership there. And then one of the things I just love is we're in every possible industry. And here is a hospital that's combining all kinds of patient data, DNA, the patient record, and trying to predict, what to do for a patient and what the outcome is. We've made it possible because of the speed up we've given them and being able to combine all this data. I'm going to skip that because I realized it had confidential on it after I put it there. So one other really fun thing we had happen this year was Pokemon Go launched on on Google Cloud, and they had predicted what the load. What they did was 50 times what they had predicted they would do, and that was just their first launch. And so it was just a phenomenal effort to spread all that data and let it all work fast enough for them, because it hadn't necessarily been architected for it. And then we would systematically roll out every new country. And like, for instance, Japan, we knew everybody in Japan was going to use Pokemon Go, so we waited a week. And we also thought they would have zero tolerance for something going down. So, so it was a very, these kinds of projects are really fun, because then it's, of course, you see it happening in the world, and everybody walking around outside with their Pokemon Go. So machine learning and AI has just become this massive change in the kinds of deep insights we're getting. As you all know, I don't need to tell you. When I was in grad school, I had a few friends that were doing neural network stuff, and they literally could not get jobs. That was in 1988. And they knew it was the future, but and part of the problem was the compute just wasn't there for it, and the data sets just weren't there for it. And the more compute we got, and the more able we were able to support data sets. I think ImageNet, I think Feifei is talking to you a little later today, what she put together was really cause machine learning perhaps to take off, because all of a sudden everybody could compare their results and improve on it. And that combined with just tremendous, Moore's law doubling, and then being able to share all that data because of the cloud has made it really exciting. And one of the things we're doing at Google is we want to democratize AI. We want to make it really easy to use by everybody in the world. and we've just invested so much in it. We even build specialized processors to speed up inference and learning and so forth. And we open sourced our framework for it. A lot of you are familiar with TensorFlow for deep learning. And we're investing a lot in helping that. We're doing other kinds of AI as well. But and Google's, just bringing this to the world in all kinds of ways. So we have APIs for data sets we've learned on, like image recognition or speech translation we're getting, so we can do really real-time automatic, simultaneous speech translation, which, what a wonderful thing for the world that people will be able to just talk to each other regardless of their language. And then we have the machine learning models that we help people build, or they can build on their own. And then we've infused all of Google's products with machine learning. I mean, there's thousands of projects going on at Google to incorporate machine learning into whatever it is anybody's building. One example in my group is we have Gmail, and then there's this inbox, which has been an experimental thing, and we put this smart reply in, which is sort of an optional, sort of beta thing, and that already has 12% usage where you just reply to your email. And Prabhakar Raghavan, who did that, was telling me that when they started, it was just too expensive to do and took too long. And he said, he kind of regards that as something interesting for people to look for, because then it's a matter of being smart about the algorithms and getting it more and more efficient. And now we, to where we can afford to do smart reply, we can do the computation. Part of that is because we have these specialized processors. This was an example, YouTube with copyright, detecting copyright violation. Robots, we put, this is a bank of robot arms learning how to pick something up, and they have a little camera on them, and if it closes all the way, it knows it didn't pick it up, and if it doesn't, then it did, and so it can mark the results, and then it refreshes every night and gets smarter and smarter. One of the cool things about machine learning is the more you learn, the smarter you get, and it never goes away. I mean, if you think about us, we learn our skills and we get better and better and better, and then we retire, and the next generation comes along and learns all the skills. And now with machine learning, we actually have a mechanism not to lose all that knowledge and to keep growing it and to help us with that. And it's truly a great thing. To the point about displacing people, I do believe machine learning is displacing jobs. There's no question about it. We have an example where we had a company, Airbus, looking at satellite images and removing the clouds, and they had a lot of people doing this, and the machine learning is way more accurate and no more people are needed. There will be other jobs and people can be retrained. Not everybody's going to be retrainable, and I think our society really needs to embrace people that get displaced and, tell them they're heroes and make them feel valued, because not everybody's going to go find another job. But there will be plenty of jobs. Their kids will all have jobs. There's no doubt about it. This is an example where a cucumber farmer used TensorFlow to do deep learning. They have an assembly line of cucumbers, and they sort them, and automatically they recognize the different sizes and put them in the right bin. This I love because I love the ocean, and one of my best friends does dolphin research in Shark Bay, Australia, where they have a lot of sea cows. And humans they're endangered, a threatened species. You look for a sea cow, and oh, there it is. This is a sea cow. And it's gotten up to 80% of the accuracy of people looking for it, and it's a very tedious, as you can imagine, process to look for these sea cows. So, there's a lot of wonderful things you can do with machine learning. We used it, this is our data center. We do everything we can to be carbon neutral, to reduce our power. We've been optimizing it. The humans have been optimizing it for, all 16 years. And, humans they were down to where they were getting 0.5% improvement and whatnot. And so then we took all the inputs, the weather, the configuration, the pipes, the pump settings and so on, and fed them all in. And we were able, you can see the low line is where we turned on the machine learning. We were able to get a 40% reduction in the power usage for cooling, which was a 15% power saving overall. And that just wouldn't have, a human wouldn't have done that. So it's pretty exciting to be able to get these kinds of leapfrog or quantum leap in improvements. There are people working on, a general purpose way to just feed the data in and smart insights come out, and it doesn't, necessarily have to be trained. Here's another fun example where this was actually published in the Journal of Medical Science. I'm not saying that quite right. Diabetic retinopathy, which is a disease that blinds people, and 400 million people at risk. And with machine learning, it was able to diagnose it. Humans had so much variability. You rate it 1 to 5, and within a few hours, 2 humans would give a completely different rating. And then now it can be diagnosed anywhere in the world, even where you don't have an expert. So just terrific stuff. And here's a fun creativity one where you give, an artist's version, in this case Van Gogh, of something, and then you take that and apply it to other images and get fun, interesting results. This is, I think, the Google Cultural Institute did this. So, that was just kind of a fast smattering of both my life and a lot more detail on my life right now at Google Cloud. I just want to really encourage everybody here to, yes, pay attention to your strengths. That's phenomenal advice. And I wasn't ever smart enough to do that, but I definitely paid attention to what excited me. And I've always done that. And I've never, people say I have a high tolerance for risk. I actually don't. I always think about, well, what's the worst possible scenario? And, I could be fired, and I once lived in a tent on someone's deck in Hawaii, and I think it was the happiest I'd ever been. So I know I don't need money, and so you can just, if you're more likely to get to do more and go, do more, explore and realize your talents to the fullest if you're a little less conservative about something going wrong. So I always like to, really encourage people to try and those worries about things going wrong, try and kind of just put them behind you and go forward. And I can guarantee anybody watching this in this room that's doing data science will always be quite employable. So if you get fired, someone else will certainly give you a job. Yeah.
Diane, what's your suggestion for people starting out new in the data science field? What kind of a skill set should they be working on?
I think I like the fact that I did engineering because I think it was rigorous, and it taught me how to think rigorously and analytically about things. If you're already in data science, you probably have that. I always think also that the more detailed you get about something, the more you learn that's generally applicable, because you really understand what it means to take something very deep. And once you can do that, you can, that kind of replicates to any kind of project you want to take on or learn about. And, you know, it depends what you want to optimize for. You know, if you want to optimize for money, I would do machine learning for financial services. And if you want to optimize for, you know, helping the world, I mean, health has so much low-hanging fruit, things that you could bring to all over the world, and it probably is going to have a, I mean, there's ways to make money, but it's going to, some of the really ambitious projects are going to be pretty delayed, I would think. Yeah. But what you're interested in would be, you know, excited about. But, you know, machine learning is the big revolution, I think. Yeah.
I was going to stand up as well. Hi, thank you so much for your keynote.
Yeah.
I want to go back to your comment on machine learning and how it's going to displace jobs. So can you, go a bit more in depth in how you see, how should society react to that? What are the societal and ethical challenges, and maybe some solutions to that problem?
Yeah. Well, okay. Skilled people are not going to lose their jobs. There's new jobs that they can very easily do, and it's about training, and it's very important that I think we make sure that everybody we're educating is coming up with, is basically computer literate is a good thing, and so the young people are all getting good educations. That's very important. I think people nearing retirement, I think companies, the world needs to value those people if their job maybe has changed and they're just not, at the point in their life where they're going to learn something new. There are companies, I met with a CEO of a German company recently who they are in the publishing industry. They shut down a printing plant for obvious reasons. And there were 300 people, and they did a 3-year program where if people, they could leave immediately and take a package, or they could spend 3 years doing their work on a more part-time basis and also getting retrained for something else. And I think it's just a matter of the world at large embracing this, educational institutions embracing it, online learning is super helpful, and then it's a matter of each company, thinking through if it's their people, how they're going to manage it. This has happened before in the world. It's not the first time. The Industrial Revolution had some dislocations, and we'll certainly get through it and just be humane. Yeah.
We have a Twitter question.
So we have a question from one of the regional events, and they want to know, how do you think that data science is going to affect the developing world, like South America?
One of the things I love about the cloud is that it makes all these resources available to anybody in the world, no matter where you are, and it makes all these incredible tools available. And so, if you have a really good idea, it's not so hard to bring it to life. And I think machine learning is getting easier and easier to use. There's already, APIs for machine learning that, around natural language processing, image recognition, and so on, that you can easily use. And so the people in South America are empowered to solve local problems, using these powerful tools. So, whether it's some kind of putting the farmers in touch with the sellers, or or getting medicine to somewhere where, medical diagnosis to somewhere that doesn't have enough doctors, you name it. It's just the local people, if they know how to use these tools, they will create new solutions to whatever their local issues are. I'm not an expert in exactly what South America needs.
Thank you.
As machine learning infiltrates more and more of every single part of our lives, I'm wondering how you think about the fragility that introduces into a society. So, by which I mean, if in 50 years everyone is driving a self-driving car, and then the self-driving car network goes down, do we all get stuck at home because no one knows how to drive anymore?
Would that be so bad?
I live in LA, no.
Our whole world depends on power. I think it's not even machine learning. I think it's power. If the power grids goes down, things are going to be really, really disrupted. And, you sort of want the powers for good to get us in a place where we can, not have bad things happen. And I'm a sort of an eternal optimist, and so I think that will happen. And not that I don't pay attention to bad things and try and fix them, but, and so, there's a lot we don't know that we used to know. It used to be to write a program, you had to know machine instructions. You don't have to know that anymore. It's okay, you can still write code. And, but I think it's about power, energy, not having access to power. And we are developing alternative forms of energy at an increasing rate, and we're also reducing, maybe someday we'll get as efficient as our brains are. That would be great. We don't use much power for what we do. Yeah.
Well, with this, let's thank you,
Okay,
Diane,
thank you.
for a wonderful talk and Q&A. Thank you.